Okay. Yeah, so I guess I can give the background for this app, and then we can get into details. So this app, it was written by one of my friends and myself, and we started thinking about it towards the end of 2015 and early 2016. At the time, well, my friend and I, we were working at a big company, and when you work at a big company with lots of legacy software, you don't get to choose like the language you use, the frameworks you use, and there's a lot of things that you have to just work with. And in some ways, it's good because it kind of limits you what you can do, but at the same time, you don't get to play with the newer technologies, and then that can be frustrating because every time you want to do something, like you have to go through these layers or layers of legacy to get something done. So with that in mind, we said, why don't we work on a simple app over the weekends and just use whatever technology we want and see what we can come up with, what we can come up with. Yeah. Okay. Yeah. You have the slides now. Cool. Yeah. And let's see if I can move the slides. Um, what do I need to do to? Oh, okay. Okay. I can move it. Cool. Is it just one sec? Let me make sure. Is it me moving the slides or is it someone else? Because there's a lag. Okay. I think it seems like working. All right. So again, yeah, as I was explaining, so we were kind of saying, okay, why don't we just do this after work, use the technologies that we want and see what we can come up with. So that was the idea, and then it just evolved over the years into this mobile app with a .NET backend that I want to talk about. At the end of the presentation, I'm going to give you the links to the code, and I'm going to give you the links to basically pretty much everything you need. So if there's something you want to look into in more detail, you'll have the links for that at the end of the presentation. All right. So what is this app? Well, we we wanted to build what's called a news aggregator app. And my friend and I, we are both originally from Cyprus, and we read newspapers from Cyprus quite regularly. And the thing about Cyprus newspapers is that there's, even though it's a small country, there's a lot of newspapers, and then they all kind of talk about similar things, but it's also different. So what we wanted to do is we wanted to read all the newspapers feeds from different news sources, and then kind of filter them out a little bit and then display them in a nice timeline on the mobile app. So in this mobile app, you would just open it and then see news from Cyprus from various sources, but it was displayed in a nice clean timeline, so you don't have to go through all these different news sources. That was our idea. My friend he's a front-end developer. I'm a back-end developer. So the idea was that he would build the front end, I would build the back end. And the initial version we worked towards the end of 2015, early 2016, over a few weekends. He worked on the front end and he used Ionic framework. For those of you who might not know, Ionic, it's a mobile framework, and you write your code in JavaScript, but then you can deploy to iOS and Android. We chose that because we didn't want to rewrite our application twice in Java and Swift. Instead, we wanted to use a single code base because that way you can optimize. And then also these mobile frameworks, they're not so great if you want to do complicated things in the mobile app. So if you want to optimize for memory or if you want to do something custom, then these frameworks can be challenging. But if you want to do something standard like displaying a timeline, then for that they actually work. So that's why we went with Ionic. And then I worked on the backend, and the backend was written initially with ASP.NET. I think the version was 4.6. It was a Windows application, and we hosted on an IIS host. And this IIS host, I don't remember which one it was, but it was basically a random host that I found that seemed to work, and it was cheap. So I'm like, okay, let's just host it there because this is an initial prototype anyway. And then this ASP.NET backend, even though it was a single ASP.NET app, it was really three separate services, but they were all bundled together. It was just a single thing. These three services, they're reader, transformer, and web API. The reader would go and fetch the RSS feeds from various sources that we defined. And then the reader would get these feeds, and then it will pass it to a transformer. This transformer, the job of the transformer was to get these feeds and put them in a common format. Because all these feeds, even though they kind of follow the same format, like they're all RSS feeds, their format was different. Like, some newspapers, they had certain things like the title and description and summary. Some newspapers wouldn't have the summary, but they would have the description. So the news format was quite random for each news source. So in this transformer, we would basically look at each news source and say, okay, what is this news source, and how can we transform them into this common format that we want? And this common format basically had the basic things that you expect from a news article, like the title of the news article, a summary, a link to the original article, and the date that it was published. So we would just extract those and then put them into this common format. And once we have that, we would expose this information to a web API, so ASP.NET Web API, and then the mobile front end would just get that information displayed in the timeline. So this was the early prototype, and the good thing is that it worked. It was the prototype that the most viable product, and it worked. And it was very easy, because even though we had three separate services, they were all bundled together. They were all deployed together. Deploying was just literally go from Visual Studio and just right-click deploy and just enter your host information, and that was it. So in that sense, it was quite easy to get up and running. But at the same time, we had problems early on. For example, we already had too much coupling between our services. The reader, transformer, web API, even though they were separate services, they were bundled together. And you could see this in the code as well. Like in the code, they had dependencies that have had. As we deploy them, again, we were deploying them all together. So all this bundling was still already a problem at the beginning, and we knew it, but we just ignored it for the time being. The developer experience of the IIS host was not great, because this IIS host, as I mentioned, it was quite inexpensive, but at the same time, it didn't really offer much other than hosting. We weren't like dedicated hosting, so we were being hosted on machines where there were other applications, and sometimes the app would go down, and then our application would go down, and we couldn't predict why, or we didn't know why it went down. Simple things like logs, for example, our application had some basic logs. We couldn't see them immediately. We had to actually log into the machine, download the logs, and then bring them back, and then look at them to figure it out. So the development experience wasn't ideal at all, but that's what you get when you have an inexpensive solution. And our application was totally not resilient. I mean, we didn't have any redundancy, so we had a single machine running our application. So if that machine went down, the whole thing went down. We didn't have any kind of persistence, so everything was in memory. We chose that for simplicity because we didn't have that much data, so we could keep it in memory. But at the same time, again, if the app went down, we lost our data. And then no resilience, meaning if any of the services went down, like for example, the reader, sometimes it would go and read some newspapers, and then it would crash. I don't know, sometimes it had problem with parsing, sometimes it had problem with reading too much and then using too much memory. So if something like that happened, it would bring down the whole ASP.NET app, right? So it wasn't ideal at all, but it just worked for the initial prototype. And that's what you want to do when you're prototyping anyway, initially, just get things up and running. So we let this run for like a year or so, but then because of all these problems, in early, my slides, sorry, oh, there, okay. In early 2017, we started looking into, okay, let's find a better place for our application. Let's move it somewhere where it's more stable. That's when we started looking into the cloud. And coincidentally, I also started working at Google, so I was getting familiar with Google Cloud. So I was looking at Azure, Google Cloud, and other clouds as well, but then it kind of made sense to try Google Cloud and see if it's going to work there and how it can work there. So what I ended up doing is that on Google Cloud, there's these things called compute engines. These are basically virtual machines that you can get. These virtual machines, they can be Linux or Windows based. So I got a Windows virtual machine. I don't remember the Windows version, but it was probably like 2016 Windows Server version. And then once you have the Windows Server on Compute Engine, you can basically just deploy your app there as if you're deploying to the IIS host, but you're not. You're deploying to a VM in the cloud. And then the nice thing about Compute Engine is that once you deploy your app and it's running on the Windows VM, and then you configure it the way you want, you can create a template out of it. These templates, they're called instance templates. And these instance templates, they basically snapshot your VM. Like whatever you installed there and whatever you have configured, it will be snapshot. And then from these instance templates, you can create what's called an instance group. An instance group, it's a number of VMs all like multiplied. Basically, you can have the same VM but multiplied as many as you want. And then once you have these instance groups, you can put them behind a load balancer. In this case, Google Cloud Load Balancer, and then you can load balance between them. So this was quite easy to do. Create the instance template, create an instance group, put it behind a load balancer. Then all of a sudden, we had our redundancy. We didn't create many VMs because we didn't need to, but we created 2 VMs just in case the first VM goes down. We would have a backup VM. We had load balancing, so setting up the cloud load balancer with instance group is really easy. So that was just a couple of clicks. And then we also got the possibility of auto scaling. So in instance groups, you can also say, I want this instance group to auto scale using this metric, and it will auto scale with the minimum and the maximum that you define. We didn't set it up because our app didn't really need auto scaling, but it was good that we had this option. So this setup worked for us. It was easy to move to the cloud. We didn't have to change our code. We just had to configure Compute Engine VMs, take a snapshot, and then create instance groups. And with that, we got our app running in the cloud, which was nice. On the flip side, things were getting more expensive, right? Before we were paying for a cheap IIS host, but now in Google Cloud, we were paying for 2 virtual machines, and we were paying for a cloud load balancer, and we were paying for the networking cost of like ingress and outgress and things like that. Still, it wasn't expensive, but it was more than the IIS host. But so it was something that we started thinking about. But this kind of made our initial prototype something like production quality. I mean, it was still not perfect, and it was actually far from perfect, and that's why we had this talk. But it was something that could manage quite a number of people, and we also had this ability to scale if we wanted to. So this served us well for another year or two, but between 2017 and I think my slides skip twice something. Let me see. I think I should have another slide in the middle here. Yeah, I don't know why my slides are skipping. So after this 2017, I need to have another. Yeah, there you go. Okay. So this app served us well from 2017 to 2019, but there were a lot of things happening between 2017 and 2019, and these things, they kind of made us rethink our application. First thing, as most of you probably know, there is this new version of .NET Core that was coming up. And one of the things about .NET Core is that .NET Core is multi-platform. It can run on Windows, Linux, and Mac. And this was quite interesting for us because so far our application was Windows-based. And because of that, we could only deploy to Windows-based places like VMs and other places where Windows runs. But there's a lot of things in Google Cloud where you need to have a Linux kind of system, and we couldn't run that. We couldn't run our application on those systems. So being able to run Windows .NET Core on Linux was quite interesting, and we wanted to explore that at some point. Secondly, there was all this hype around containers. So everyone was talking about how to take a virtual machine-based application and how to break it down into smaller pieces and how to run those pieces into Docker containers and how it was so efficient and how it was much easier, right? So being able to run in containers would also enable us to deploy to multiple different places. So this was something interesting as well. As I mentioned, we had this Windows dependency that we wanted to kind of get rid of at some point. It wasn't crucial, but it would be nice to get rid of that dependency because we didn't really depend on Windows in a major way. And finally, as I mentioned, the cost on Compute Engine was something that we wanted to get rid of as well. I mean, this was a hobby kind of application, so ideally we would run it as cheap as possible if we can. So all these things came into play, and from 2017 to 2019, we were thinking about rewriting our application using .NET Core and containers, and then that's what we started to do in early 2019. Right, again, there we go. Yeah, in stage 2, in early 2019, we took our application and we said, okay, first we need to rewrite this in .NET Core. And this was a big unknown for us because, .NET Core, it seemed like it was something that was becoming big in .NET, but we didn't know how much of it was implemented, and we didn't know whether we could run our whole app in .NET Core. So it was something that we had to try out. And initially, I thought, it would take me at least like a week or two to figure it out. But I did it on a weekend, basically. On a weekend, Saturday, I looked into .NET Core, and then I started writing parts of our application in .NET Core. And then by the end of Saturday, I was basically running the app in .NET Core. I think Microsoft did a really good job in kind of porting .NET to .NET Core. There were slight differences between how things work between .NET and .NET Core, but they were well explained in documentation, and there were like migration guides from .NET to .NET Core that helped quite a lot. So in the end, we could rewrite our application with minimal pain. I should also mention that we could rewrite it because we had really good functional tests, and I think this is really important to point out. Our application, yeah, we had unit tests, and unit tests are good as well. You should have them. But at the end of the day, I think what saved us was our functional tests. We had tests basically that would go and fetch all the news, and it would transform them, and it would check that they're transformed properly, and it would check that they were served properly through the web API. So it was like the end-to-end testing. And because we had that, when we rewrote our application, we could rely on our functional test to make sure that our application actually works. And yeah, our unit tests also helped us, but I think the functional tests were the main things that gave us the confidence that things are working as they're expected to work. So I think it's very important before you do any kind of refactoring or transformation, make sure that you have good functional tests in place. We rewrote in ASP.NET Core 2.2. That was the one that was the latest at the time. And then once we had that, we basically broke our dependency to Windows. Now we could run on Linux or any other platform. And then that's when we could start looking into containerization, take our application and run it in a container. Again, this took like not too much. Basically, to containerize your application, you need to write a Docker file. So you need to figure out like which base image you need to depend on. And then once you have that, you need to also figure out like which configuration to add to your container. But again, like there's base images for .NET containers and ASP.NET Core from Microsoft. So by depending on those and by just using some examples from the web, we were able to containerize our application. And then at that point, we could deploy our application to multiple places on Google Cloud, because running Docker containers is very easy. In general, it's very easy, but it's also on Google Cloud, it's quite easy. At the time, we had a couple of options. One is Kubernetes engine. For those of you who might know, Kubernetes, it's an open source project, and it's basically designed to run containers at scale. And then on Google Cloud, there's a version called Google Kubernetes Engine, which is running Kubernetes within Google Cloud in an easier way. So that was one of our options. And the other option was App Engine Flex. App Engine, it's Google's platform to run containers. And there's a couple of different flavors, like the standard and the flexible version. So the flexible version is basically you are still running VMs under the covers, but then you're telling Google Cloud, okay, this is my container. Can you just run this? And it will just schedule the container and run it on the underlying VMs for you. And it would work for C# as well. So those were our two options. And we went with App Engine Flex because it was easier. In App Engine Flex, literally all you need to worry about is here's my Docker file and my code, and then it just figures out the rest for you. Kubernetes is better for applications that are more complicated, where you need to kind of be hands-on and you need to kind of have multiple services that you want to scale independently, all that kind of stuff. So if you have like quite involved requirements with different services, then Kubernetes is probably a better choice. But in our case, it was a single app. It was still a single app. And for that, App Engine Flex was enough. So that's why we went with that. So with this setup, we got rid of Windows, meaning we started running on Linux. So it was cheaper already because we didn't have to pay for Windows licensing. App Engine Flex has auto scaling on by default. So even though we didn't need it that much, we still have auto scaling, which is nice. And then App Engine also has this notion of revisions and revision management. So every time you deploy a new version of your application, it creates a new revision, which is nice because if there's something wrong with that revision, you can always revert back to the previous revision. And then once you have multiple revisions of your application, you can do traffic splitting. So you can say, okay, I want this new revision to get 10% of the traffic, and I want this next revision to get 90% of the traffic. So you can do things like that. So these were the nice things that we got out of App Engine. But then on the flip side, our application was still a single application, and it was still running on virtual machines, even though we didn't have to worry about virtual machines ourselves because App Engine was managing that for us. But we still had to pay for them, right? So we still had to pay for these VMs, which means that you pay for these VMs even though no one is using your application. Our application, and this is true for most mobile applications, is that it runs cyclic, meaning more people use it during the day and then less people use it during the night. So ideally, you would scale during the day when more people use it, and then you'll scale down to zero maybe when no one is using it. But with VM-based systems, you can't do that. You need to have a VM running no matter what. So that was not a big problem, but it was something that basically made us pay more than we had to. And deployments on App Engine Flex, they're kind of slow. It can take anywhere from 5 minutes to 10 minutes, which is not too much. But at the same time, if you want to iterate fast and if you want to change something and see that in production, it can add up. So that was also something we were thinking about in our minds. All right, so that's stage two. This was early 2019. Then around, let's see if my slides are. Okay, I want to go to the next slide, not this. So next slide, Cloud Run slide. Okay, well, I don't know. My slides are double going. They're double. So from this one, I need to go to the next slide, but it's going to. All right. Well, I'll just talk about this one. So in 2019, early 2019, this is when we did the switch to App Engine Flex. In mid 2019, there was this new thing that was announced at Google Cloud Next, which is Google Cloud's conference for new technologies. And there was this new thing called Cloud Run. And the Cloud Run, the whole premise of Cloud Run was to run containers in a serverless way, right? Because usually when you think about serverless, you think about functions. You write a function, you deploy that function, and then that function is deployed somewhere, but you don't know where it's deployed. It's managed, so you don't have to worry about what's running your function, and then you only pay for when people use, right? This is great for functions, but then in our case, we were running in containers, so you couldn't really run containers like functions. But Cloud Run tried to change that. And the whole premise of Cloud Run is basically you would just say, okay, here's my container. It can be in any language or in any framework you want. It would just run it as if it's a function, and it would figure out all the networking details of your container, will figure out auto scaling. It will scale it up and down, all that kind of stuff. But your unit of deployment is a container, and that's what Cloud Run gave to people. And this was quite exciting for us because this meant that we could take our .NET container and we could try to run it on Cloud Run and see if it works. So this happened around mid-2019. Cloud Run was announced. And one of the use cases of Cloud Run is, it's good for public endpoints, things like API endpoints or webhooks and things like that. It's also good for internal endpoints. If you want to do something internally within your cluster, but you don't want to have a public endpoint, you can do that with Cloud Run as well. So this also worked pretty well for us because our application had a public front end, but it also had internal services like the reader and the transformer. They could be internal services. So the use cases fit. The other good point of Cloud Run, again, my slides are going twice. I don't know if can we somehow fix this, please? So from this slide to the next slide, this is not the next slide. The next slide is supposed to be something else. I don't know how to fix that. Yeah, there we go. Yeah. So I don't know how to do this, but anyway. And the other good things about the Cloud Run is it's billing. In Cloud Run, you don't pay for the time your container runs. You only, okay. Sorry, I need to get to the right slide. Okay, you don't need to pay for the whole time the instance is running. You only pay for the request time. So for example, in this case, you can see that our container instance is running for a while, but then you have two requests coming in, request 1 and request 2. You only pay for the beginning of request 1 and the end of request 2. So your container might be running longer, but that's not what you pay for. You only pay for the request time. And this had huge implications for billing for us, because as I said, our application is not used during night, so it can scale down to 0, and then we don't pay anything. And then when people use it, we only pay for the time that they use it. So this had quite a big implication for billing for us as well. So with those in mind, let's see. Yeah. So with those in mind, in mid-2019, we said, okay, let's just take our application and see if we can deploy it to Cloud Run. So first, I updated to the latest version of ASP.NET. This was ASP.NET 3.0 in mid-2019. And then deploying to Cloud Run was really easy. I mean, we didn't have to change anything because we already had a container. All we had to do was just deploy that container to Cloud Run, and then it was just working. And with Cloud Run, as I mentioned, we got serverless billing, so we didn't have VMs anymore that we had to pay for nothing. It got much cheaper, so we were basically running our application for free now because Cloud Run has a free tier, and with that, we could just run our application for free. The developer experience on Cloud Run is great. You get really fast deploys. I mean, you can deploy a container within like a few seconds, basically. So that's why I don't even debug locally nowadays. If I need to do something, I just deploy to Cloud Run within a few seconds and then just try it out in there because I can. And you have other nice features like integrated logging. So once you deploy your services, you can see which services have been deployed, and then you can see their logs, and then those logs, everything that you log goes to Stackdriver, which is the logging system of Google Cloud, and then you can search for those logs. So the whole developer experience is very good. The good features of App Engine with revisions and traffic splitting and all that kind of stuff is also in Cloud Run. So you can deploy new versions of your app without getting any traffic, and then you can send traffic to it gradually. And this kind of stuff, they really help you to kind of run in the production, but not affect your production system. So it was really a good move for us, and it was really easy to do. But then on the other hand, our application was still running as a single unit, right? It was still a single monolith. And because of that, we had this monolith issues still that we had to solve. So that was the next thing that we looked at from mid-2019. We said, okay, let's just, now that our application is running in a container, now that we have serverless billing, let's actually make our application resilient and microservices-based architecture and get rid of these monolith issues. And these monolith issues, let's see, these monolith issues, they were basically, the first thing was scaling. You could only scale the app as a single unit, right? Because it was a single thing. And this was a problem because usually we wanted to scale the web front end because if more people use our app, we want the web front end to scale. But we didn't really want the reader or the transformer to scale because we don't need to read faster or we don't need to transform faster. But because everything was a single thing, we had to scale everything at the same time, and this cost us more, and it was unnecessary. We didn't really need to do that. So that scaling of all or nothing was an issue. Secondly, cold starts were becoming an issue. So as you know, in any serverless frameworks, whether you're running within a function or whether you are running within a container, you're going to have this issue with cold starts, meaning when your container scales down or when your function scales down and you don't have any function or container running, when the first person comes along and they make a request, your function has to wake up or your container has to wake up. And this waking up can be quick, it can be less than a second, or it can be long. Depends what you do in your function and depends what you do in your container. So if your container is not optimized, you could easily spend like a minute or so to wake up, and this could manifest itself as cold start because the user can see that. And it was particularly bad in our application because our application didn't have any persistence. So what that meant is that if the application scales down and the user comes along, we wake up. So that takes like a second or two. And then we don't have state, so we had to go and get state. So we had to read, transform, and then populate the state, and then we can serve to the user. So this could mean like 10 seconds or something where the user just waits, which is very unfortunate for the first user. So that was becoming a bigger issue with scaling down to 0 with Cloud Run. And because of this, this was caused because of in-memory state. If we had some kind of persistence that we could rely on, we didn't have to read all the time. We could just go to our persistent store. So we wanted to get rid of in-memory state as well and have some kind of persistent store. And finally, as I mentioned, there was no way of updating individual services because what we found out is that usually we didn't have to change the reader because the reader would just go and fetch the feeds and just read, and that doesn't really change that often. The web front end, it didn't really have to change either because we are just serving this common format that we always served. And then the transformer, the thing that converts these RSS feeds into this common format, it had to change quite a lot because all these newspapers, they change their format quite a lot. And once they change it, we need to change our rules. So we had to update this converter quite often, but we didn't have to update the others that often. But again, because everything was a monolith, we did have to update everything at once. And this was a risk because you're updating something small, but as you're updating that small service, you're also updating everything else. And sometimes this would cause issues unnecessarily. So these were the monolith issues that we wanted to tackle. And in the end, at the beginning of this year, 2020, we basically tackled these with this new architecture. So let me just go through that with you. So this is the architecture that we came up with. And first thing to point out is that we have multiple services. So first, we have a reader. This is a Cloud Run service. It's a private service, meaning it doesn't have a public endpoint, but the things in Google Cloud, other services within Google Cloud, they can authenticate and they can call this service internally. And that's what we want because if something doesn't need to be public, it shouldn't be public. So Reader, it's a public private service that all it does is it goes and fetches the RSS feeds and it saves it to a place called Cloud Storage. Cloud Storage, it's a cloud-based storage solution where you can save any kind of files. So the reader, that all it does is just fetches the feeds, saves it to the storage, and then we made Cloud Scheduler, which is also another cloud-based scheduling tool, to call the reader on a schedule. I think we just say once an hour or something like that. The Cloud Scheduler will say, okay, go and fetch the feeds. The reader would go and fetch the feeds, and then it would get them and save it to Cloud Storage. So that's service number one. Then you can set cloud storage to send notifications when something changes. So once you save a file to a bucket, the cloud storage can send a message to a pub/sub topic. So in this case, cloud storage says, okay, there's a new file. It will send a message to a cloud pub/sub topic. And then this topic can be listened by other Cloud Run services. So in this case, we have another private service called Converter. Again, this is private because it doesn't have to be public. And then all it does is it listens for pub/sub messages from this pub/sub topic. And these messages will say, okay, there's this new file in cloud storage, go and get it. So the converter will get that message. It will go and fetch the file, which is a JSON file basically of the RSS feed. And then it will use the list of rules that we have to kind of figure out which source this is and then how to convert it. And then once it converts this RSS feed into this common format, it will save it to Cloud Firestore. Cloud Firestore, it's a NoSQL database. It's fully managed, meaning you don't need to set it up yourself. You just say, give me a Cloud Firestore database, and it's there. It's managed for you, and it's perfect for JSON-like data. So if you want to have a flexible schema, NoSQL is usually better, and Cloud Firestore really makes it easier. So Converter uses that to save the files. We could have used something else like a SQL database, but then SQL databases, you need to set them up, you need to create a table, things like that, where I find NoSQL databases is much easier to work with, especially when they're managed like Cloud Firestore. And then we have a third service called Web. The Web is a public Cloud Run service. And all it does is, when users make a request to the Web API, it will just go and fetch it from the Cloud Firestore and just serve it back, right? So this is what we ended up with. And then as you can see, we don't have a single monolith anymore. We can individually update these services as we want. We can individually scale the services. So if we have more users, we'll scale up Web without scaling up Reader and Converter. Everything is event-driven, right? So the scheduler, starts the reader. Then when the reader saves a file, that triggers the converter. Then when the user makes a request to the web, that triggers a call to Firestore. And now we have persistence. So if, let's say, the reader goes down, which it doesn't, but if it goes down, then we still have something in the Firestore to serve to the users. So all the issues that I talked about with monolith, it ended up being solved by this architecture. But then at the same time, you can see that things are getting more complicated, right? I mean, instead of one thing, we have three things. Now you need to worry about more things, and you need to, have CI/CD and other things to manage these services. So even though it solved a lot of problems, now the complexity is also more. But that's the price that you have to pay when you're dealing with microservices, and you should be aware of that as well. All right, let me see my next slide. I think this should be the next slide, but yeah. Okay, so the lessons learned in this whole transformation, I want to just recap this for you before we can look at some questions and answers if there's anything. First of all, as you've seen from our application, the transformation, you don't go from like an app running on Windows VM to a microservices architecture running on Docker containers overnight. It just doesn't happen. And if you try to do it, you're gonna fail probably. But what you can do is basically what we did. Like you can try to make your architecture better and better as you go along. And each step can help you to get better in your architecture. So I think you should see transformation as a journey rather than something that has to happen now. It's something to keep in mind. And then as you are doing this transformation, you're going to have non-optimal solutions or architectures in the middle. For example, in our case, when we went from VMs on IIS host to VMs on Compute Engine, this was a good move. And I think it just enabled us to be more resilient by not changing our code. But then when you look at our transformation from VMs to containers to App Engine, and then from then to Cloud Run, App Engine was the non-optimal solution when you think about it, right? Because everything about Cloud Run is better. It's serverless, it scales down to 0, it's faster, everything is better. But at the time, we didn't have Cloud Run. We only had App Engine. So it was a non-optimal solution, but it was a necessary solution that we had to do along the way. But by doing the transformation from VMs to containers to run them on App Engine, we kind of got ready for the next phase or to Cloud Run. So sometimes you might end up with a non-optimal solution, but they actually, as long as you're making the right decisions, um, they help you along the way later when you can actually run on a better platform. So keep that in mind as well. Don't try to be perfect right from the beginning because you can't be. And these small steps, they each help. Um, Again, like at some point in our application, we had to change our code, but then in many parts, we didn't have to change our code. Like going from IIS to Google Cloud, there was no code change. It was just configuration change. Again, going from App Engine Flex to Cloud Run, there was no code change. It was just deploying to Cloud Run. So don't think that you have to change code all the time. It can be as simple as just finding this new environment and finding how to configure for it and deploy there could give you a lot of benefits without code rewrite. But having said that, at some point, if you truly want to take advantage of the environment, you need to change your code, right? Because when we initially went from App Engine Flex to Cloud Run, we didn't change code and it worked, but we didn't get the benefits of Cloud Run. We weren't really using scaling down to zero. Even though we were scaling down to zero, it wasn't really helping us that much. Um, and like to truly really take advantage of Cloud Run, we had to decompose our application and make it event driven. That's when we actually realized the benefits of it. So you should keep that in mind as well. Like, a new environment can mean no code changes, but then in some cases where you truly want to take advantage of this new environment, you need to think about, okay, how can I change my app from this style to the event driven style, and what do I need to do? So that's why it's very crucial, I think, from the beginning to make sure that your services, maybe they're not totally separate in code, like in reality, but you try to keep them separate in your code. You can still deploy everything together, but you can still have separate libraries, and you can still try to keep things separate. And you can still have tests for them separately. By doing that, you can make this decomposition much easier later on. And this whole idea of taking a single monolith and breaking it down into small microservices, it can have huge benefits, but it's also very difficult to do. Even for a simple application like ours, it took a lot of effort of refactoring your code, refactoring your tests, rewriting your code for this new environment, rewriting your code to decompose things, creating common libraries, and all that kind of stuff. So make sure you have a good reason for it. Don't just do it because people tell you to do it. It will take time to decompose. It will take time to create the microservices, and it will be harder to manage microservices because you have to have tools in place and you have to look at multiple things now. So you have to have a really good reason to do this decomposition. In our case, the reason was to improve the resilience of our application and to improve our billing and make it like, truly the request-driven billing. And that's what motivated us. So make sure that you have that motivation as well when you try this transformation in your applications. I think that's all I have. If you want to look at this app in more detail, I have a blog, and on my blog, if you just go to tags app modernization, there's actually 4-part blog series where I talk about this app in more detail, so you can get even more details than I explained here. If you go to GitHub, my GitHub page, there's a section called Amathus, which is the name of our application. You can see there how I set things up, and there's some good things there. Like, for example, when you build Docker images that depend on common libraries, it's actually quite tricky to get it right. So I have some scripts to do that. So if you need to do that kind of stuff, make sure you check it out. And then if you want to learn more about Cloud Run, I also have a tutorial on GitHub as well. So you can check out that tutorial as well. Yeah, sorry for the issues with the slides. Sometimes I skip twice, but hopefully you get the idea of this transformation, and hopefully this was useful to you. So I'll end my talk right now, and we'll see if there's any questions and answers.
Yes, thank you very much, Meta. It was very interesting journey, the division of monolith application into microservices and putting it into the cloud, Google Cloud. Well, guys, who is listening to us, I want to remember you that we have a Telegram chat where you can ask questions to Mete. Okay, the first question which we have, why did you choose to use Ionic framework? Why didn't you choose Xamarin, for example, or something else?
Yeah, that's a good question, and that was totally not my decision because, as I mentioned, my friend was like the front end, and I was the back end guy. So I made the decision in the back end, but he decided Ionic framework. And I think the reason is because he's a JavaScript developer, and Ionic framework is a JavaScript framework that I think works with Angular, and now it also works with React as well. I think that was our main motivation. But I agree. I mean, if you're a C# person, I think Xamarin is probably better. And nowadays, there's more choice. There's also Flutter from Google. That's in it's not in TypeScript, but it's in the Google's language. I forgot the name. Dart. Yeah, it's in Dart. That I also heard really good things about that one as well. So there's more option now. But back in the day, we basically just said, okay, what is a JavaScript mobile framework? And Ionic was one of them, one of the main ones. So that's why we went with that. And I have to mention, I also have very mixed feelings about frameworks, especially mobile frameworks, because this whole idea of like writing once and deploying to multiple places like iOS and Android, it kind of works, but it also doesn't work because there's like small things that you need to do and you need to change. You're always dependent on the framework, and for the main things it works, but then as soon as you want to get out of their main use cases, it becomes very difficult to kind of do the customizations that you need. So I'm always split between, should we use a framework or should we just go with like pure like Java and Swift or something? I don't know the right answer because I don't know much about mobile development. Yeah.
Okay, thanks. But when you choose made the decision to rewrite your application into modern, why didn't you choose, for example, Dart or something else? Why .NET Core?
Oh yeah, I mean, so the backend was already written in .NET, and we wanted to reuse the code as much as possible. So my initial idea was, okay, let's make this work in .NET Core because the code is already there. And if so, we'll use it. If not, then at that point, I will look into another language, right? I was thinking maybe I can rewrite it in Go, because Go nowadays is kind of the hot language when it comes to backend services. Or I could try something like Python maybe. So I was kind of open with the language, but then I was pleasantly surprised. I mean, once I ported the .NET C# code from .NET to .NET Core, it just worked. And there were slight things I had to change, and I had to update the NuGet dependencies to the .NET Core versions. But it just worked, and then, since it works, why change it? And at this point, I mean, even though we have three separate services, and even though they are all written in C#, there is no way why we cannot replace one of them. For example, we can change reader to be in Go if we want. And that's kind of the beauty of containers, is that once you containerize things, like you can run any language in that container. Like nobody cares. So if you have a favorite language and you want to write that, just do it. As long as you give Cloud Run a container, it will just work. But yeah, I guess my main motivation was code reuse, because I don't want to rewrite things just because there's a cooler language.
Okay, thanks. The next question, do you use any rate limiter or something like that to be sure that a DDoS attack will not make you pay extra money for your cloud services?
Yeah, so I don't use any kind of DDoS protection myself because I don't have to. That's a good thing about Google Cloud. So in Google Cloud, any service that you deploy, this can be Cloud Run, this can be App Engine Flex, or even Compute Engine, there is default DDoS protection at the network layer. So the Google Cloud networking will actually look for DDoS, and then it will cut down connections if it feels like there's a DDoS attack. So that's why, because of that protection, you don't have to actually do that in your code. So that's number one. And the second thing is that there's also products like Cloud Armor that can also, it has lots of security features that you can put around your services, and that gives you another level of security as well. So all of these security related things are kind of baked into the platform itself, and you don't really need to do like that, what I call the basic security in your code, and you can instead focus on things like authenticating users or things like that. Of course you have to do that, but the rest, the rest of the things like the basic like DDoS protection and all that is already taken care of by Google Cloud.
Okay. And do you use any cloud armor or something else to protect your application?
For this app, I don't think so, because I never had a problem. Maybe I should, but it is an option, yes.
Okay. I think after this talk, you will have a huge amount of requests to your application. New users,
Well,
billions of users.
we'll see. I have protection. I have the monitoring set up. So if that happens, yeah, I will quickly enable things like Cloud Armor.
Okay. Okay. The next question: how do you test your new features locally? Have you in a sandbox? How does it work?
Well, how to test your features? Well, I mean, at the end of the day, you are basically running .NET Core code, and you are also running containers. So it's similar. I mean, you can test everything locally. So you can run .NET locally if you want, and then if you want to test the actual container, you can run Docker locally and test it that way. So, but one thing that you need to pay attention to is, when you build your dependencies, it's very easy to depend on cloud things, and then by doing that, you kind of lose the ability to debug locally. And just to give you an example, for example, our application depends on Firestore to store the files, right? Well, that's good, but then if I want to debug locally, then I don't want to depend on Firestore, a cloud service. So what I did is, if you look at my code, for example, I made this store, like this actual thing that we store files, pluggable, and then I also implemented an in-memory version of it. So, right? And then when I do run, so when I run application locally, I don't use the Firestore one, I use the in-memory one. That way I can still run my app locally, and I can still get the feeds, and I can still store them in the memory and debug through it, right? So you need to make sure that your local debug, like the ability to debug locally, is still there by making sure that your dependencies, you can kind of also localize them if you need to. But once you do that, it's just pretty much the regular .NET Core debugging. And I don't really need to debug through Docker container, because usually like nothing is different within the Docker container. The only time that I need to debug Docker container is when I need to, say, add a new configuration or something, and I need to add that file to my Docker container image. Then you need to test things out. So that's the only time when I actually like run the Docker container, make sure that it still works, and then you can push it to Docker Cloud Run and then test that it works there as well. And then yeah, there you go.
Okay, thanks. What deploy strategies can be used to run, and what deploy strategy do you use in your application?
What deploy strategies are used? I guess, I mean, do they mean like CI/CD, or do they mean like how do I deploy my application?
I think here is about like canary deployment or blue-green deployment or something, some else.
Right, right. Yeah, I mean, so the nice thing about Cloud Run is that you can basically you can do a deploy, you can do a silent deploy, meaning you deploy a new version of your application, but it gets zero traffic. So that's what I do usually, initially. Like I say, okay, I have this new version, let me just deploy that with zero traffic. With that, you still get a URL for your app, but the URL is not the main URL. It's just a version URL. So what Cloud Run does is that it creates a new version of your application. So let's say you have version 1 running, it creates version 2, and then it also gives it a separate URL, and then I can go and test it out on that URL and make sure that it works. And then once that's the case, I mean, what you should normally do is that you should gradually ramp up traffic, meaning first you probably want 50% of your traffic to version 2 and then 50% to version 1, and then make sure that things work, and then gradually increase version 2 to 100%. But what I usually do is that, I mean, since this is a simple app, and once I test it out with the silent deploy, I just switch it to traffic settings, and then I just get the new version, have 100% of the traffic. So that's what I usually do. But what I would recommend to do in a highly used production kind of app is to do a silent deploy, do some testing on that version, then gradually ramp up traffic to that version until it's 100%. And Cloud Run makes this really easy because it has the idea of revisions, it has the idea of traffic splitting, it has integration with Google Cloud Build, which is basically a CI/CD tool to build containers from a GitHub source, and then deploy that save that container to Google Container Registry, and then deploy it to Cloud Run. So all that you can set up yourself. And actually, if you look at my code on GitHub, you can see that I'm using Cloud Build to build my services. Yeah, so that's what I do nowadays. But there's a lot of complicated things you can do if you wish.
Okay, you mentioned that you are using a Google Cloud Build. Can you please tell a bit more about Google Cloud Build and its integration with GitHub and its build tools,
Yeah, I
CI/CD?
mean, yeah, sure. Google Cloud Build, it basically allows you to go from your source code to a container image in Google Container Registry. So Google Container Registry, it's kind of like Docker Hub. It's a registry for images, but it's for your Google Cloud project. And Google Container Registry can be public or private, so you can have public registry for anyone to pull and push from, or you can have private registries as well for your project. And then what you can do is that in Cloud Build, you can say, build this image, and then you just point your Docker file and your source code, and then it just builds in the cloud. So you can basically just submit it from your laptop, and then it will take your code and then build it in the cloud, and then it will create the image, and it will save it to Google Container Registry. And then from then on, you can use this container image anywhere you want. And it has integration with various things like GitHub and Bitbucket and all that. And then you can set triggers. So that's, for example, like if someone checks code to this branch, then you trigger a Cloud Build job, and then Cloud Build just looks at that branch, pulls it in, and just builds it. Everything is configured through YAMLs, which I don't know. I mean, I'm not a big fan of YAML, but at the same time, like, there's not much else nowadays. So in your YAML file, usually it's cloudbuild.yaml, you specify the steps that you want, and what needs to happen in your app before it can be built into a container image. So it's similar to other tools out there, but I would say it's more specific to Google Cloud, and especially if you're working with Cloud Run. In Cloud Run, there's, like, if you go to your Cloud Run service, at the top there's a section that says enable integration with Cloud Build, and then they basically set things up for you automatically so that you can do this Cloud Build CI/CD pipeline. You get like a default CI/CD pipeline basically from Cloud Run and Cloud Build. Yeah.
Okay. The next question: what was the hardest part for you of all of this journey?
The hardest part. That's a good question. Let me think. Yeah, I think. Yep. I mean, probably when I look at it, well, two parts were kind of tricky. Like, first, rewriting the code, like from .NET to .NET Core, I expected it to be much harder, but it ended up being easier. But it was only easier because of the test. We had like good functional tests, and because of that, it ended up being easier. But I can imagine that being hard for for projects who couldn't be harder, who don't have like functional tests, that proper functional tests, or who are not that simple. They can run into problems because there's lots of things that change between .NET and .NET Core, and they're usually small things, but they're small, but they each take time. So that can be quite challenging for people, I think. I mean, for me, it wasn't that much challenging, but it could be. And I think the hardest part for me was definitely breaking the monolith because I thought our code was like modular and it was, quite modular, like with three different services, and I had like a common library as well. So I thought I could just easily take those and just break them into like separate services. But then when I actually started doing that, I realized, okay, this code is actually depending on this. Like it's not really that separate as much as I thought. And even if things are separate, you still need to think about new issues. Like for example, normally if everything is in one process, you just do a method call, right? This calls that, and it's just simple. But then when you separate them into separate services, then you need to answer the question, okay, how does this service call that service? Like how is it supposed to be? Do I need to make an HTTP call? Or do I need to receive a message, And if it's a message, like what kind of message should I receive? What's the event? And then once you have the event, what's the format of the event? Like, is this event like a cloud event? Because cloud event is a common format for events. Is it a cloud event that I should expect, or is it a pops up message event, right? So all these like small things, like where you make a method call, they end up becoming bigger issues. So yeah, even though your code might be quite modular, um, breaking it down creates the separation, and this separation means that you need to think about how the communication should happen. And there's all these other options that you need to consider. So I think definitely like that breaking the monolith was definitely not the hard part, but the part that you have to think about quite a bit.
Okay. Uh, well, guys, we already spoke about it, about why do you choose such technologies like .NET Core, Ionic, and etc. But guys in chat wants to drop you off from the .NET and ask, have you ever thought about changing stack like Java, JavaScript, Dart, maybe now, maybe in future? Have any thoughts about this?
Yeah, yeah, and I mentioned this already. Like I thought about Go because Go is a good language for
Mhm.
services, and I can totally see like the reader being a Go service, or even the transformer being a Go service. Um, I mean, Web API, I kind of like ASP.NET Web APIs. I mean, they make sense to me, and I've been using them for a while. And I think the tooling around like Web APIs in general from Microsoft is really good. So I don't have a strong reason to change that, but it would be nice to try out. Like maybe if I write different parts, a new part to this app, maybe the new service I'll try something else. But again, like I feel like these languages, I mean, I don't know, like no matter what language you use, like in the end you get the job done. I think certain languages they're better. Like for example, Python is probably better for data processing and machine learning because most of the machine learning frameworks they're in Python. So I wouldn't try to use say C# in Python, sorry, in data processing. But other than that, like most of these services and web APIs, they can be really in any language. So I don't feel strongly about it. Yeah, that's my answer really.
Okay. The next question is about containers. Yeah, you already told in your speak that you choose the Linux container, but and that it is a good point to switch from .NET Framework Full to the .NET Core to leave dependency from Windows. But why didn't you choose to host your Windows all up in the Windows Container Docker?
That's a good question, and thanks for reminding me that. So at the time, Windows containers they were there, but I think it was either alpha or beta or something like that. So I wasn't sure. I mean, I could have tried, and I could have said, okay, let me run this my app in Windows container. Maybe it would have worked, but then once it worked, I couldn't really deploy. I could deploy to Google Cloud, but I could deploy only into a VM at that point because Windows containers they were only supported on VMs. So that would be pointless for me basically because I already have a VM-based application running in Compute Engine. What I would do is I would run that in a Windows container again on Compute Engine, and in the end I didn't really gain anything, right? Now that thing changed actually, and now you can run Windows containers on Google Kubernetes Engine, so you can have Kubernetes manage your Windows containers. So that could be an option. But again, like I didn't really want to get into Kubernetes because Kubernetes, it's for more complicated applications where you have more services and where you need to scale them individually. And then once you get into Kubernetes, you have this whole Kubernetes problems that you have to deal with. You have like Kubernetes deployments and Kubernetes pods. You can't just take a container and deploy it. You have to create a pod definition. And then from there, you have to create a Kubernetes service. Then you have this ingress rules that you have to configure with Kubernetes. So it's a whole different world. And I really didn't have a strong reason to get into that world, at least with this application. So that's why even if I could do Windows containers on Google Kubernetes Engine, I probably still wouldn't try it. So my first goal was, let me try to rewrite this app in .NET Core. And if that doesn't work, maybe I could have looked into Windows containers. But if it worked, that would open up a lot of opportunities for me, right? And that's what happened. Like since I did that right, then after that I could do App Engine Flex, and after that I could do Cloud Run. So yeah, that's my answer basically. Yes, definitely. I mean, if you have an existing application and that application is a legacy kind of application, but you still want to run it in, say, Windows containers or Kubernetes, then you can totally use Windows containers now, and that's an option. But I mean, my recommendation would be if you can rewrite your app in .NET Core, if you can do that. I mean, that's a big if because I know it takes time and not all applications can be written in .NET Core. But if you can do that, it's something worthwhile to consider because that is the future of .NET. So you don't want to be left behind basically with your application by just keeping it on Windows.
Okay, thanks for the answer. We're talking about technology of your application, about architecture, but tell us a bit more about your application. Is it a high-load application? How many users do you have, requests per second, or something else?
No, I wouldn't call it a high-load application. It's basically mostly people from Cyprus that use this application because it's a Cyprus newspaper app. I don't know I haven't checked it recently, like how many people use it, but I don't know. It's probably like hundreds of users, like per day. I wouldn't say. I mean, sometimes it's probably like it gets to thousands, but it's not like 10,000 or a million people. No, nothing like that. Um, and we don't promote it either. I mean, I talk about this. I talk about it here, like and in some other places, but then we don't do any marketing or we don't do any kind of campaigns on it. It's like an organic kind of app, and we want to keep it that way because it was meant to be an app where we just use technologies that we like and learn from it, and then maybe talk about it like in places like this. But I don't want to. I don't want to like scale this app or make it like a full-time kind of job because I'm already quite busy. So that's why we're kind of trying to keep it like, okay, it's a useful app, let's just keep it and let people use it. But we don't try to kind of scale it anything beyond that.
Okay, thanks. What is the biggest problem in the new architecture with microservices?
Biggest problem. Um, I don't know. What is the biggest problem? I mean, I
To
wouldn't
your
call it a
mind.
problem, but yeah, I mean, I wouldn't call it a problem, but I guess it's just the nature of microservices is that compared to like a single monolith, now there's so many things to worry about. Like if something doesn't work, I guess this is a good example. Let's say I realize in my application that one news feed is not displaying my app, so something is wrong somewhere. Now before I would just go to my monolith and look at the logs, and then there's an exception, and I'm like, oh, okay, this doesn't work. Just fix the exception, push it out, and that's it, right? Now it's not like that. Now I need to look at logs of 3 microservices and see if any of them threw an exception. And sometimes there's an exception in both places. And then I say, okay, like the reader, is it reading? Yes. Then I had to look at the storage to see if the actual JSON is there, right? So there's more places to look at now. I mean, that's what happens like when you break one thing into multiple things. And because of that, you need to look at multiple places. So I guess the biggest challenge with microservices is, I think, monitoring them and then maintaining them and then debugging them, right? Like, so if there's something wrong, where do you start debugging it? Do you start the whole chain, or can you just start one microservice and then debug that, it could be more challenging. Yeah, so the whole management of your app gets more complicated, and I think that is the challenging part of microservices.
Okay, thanks. Well, you already told us why you choose the Cloud Run, but what if one is not working at Google or some other corporation which has a cloud and wants to choose cloud platform? What is the key differences, for example, from the AWS, Azure, others? What will be your recommendations when one will start the new application and wants to choose a cloud platform to run Docker containers using Knative or
Yeah,
something else?
yeah, exactly. That's a good question, and thanks for asking that. So first of all, I should mention that Cloud Run is based on an open source technology called Knative. And Knative, it's basically the same thing as Cloud Run. It runs containers in a serverless way, but it can run on Kubernetes, anywhere there's Kubernetes. So if you're running Kubernetes locally, if you're running Kubernetes in Azure or AWS, you can install Knative and you will have all these sorts of features I mentioned with Cloud Run on Knative. So that would be my recommendation to people, is that if you want to do this yourself, or if you don't want to be tied into Google Cloud, then just still write containers, because containers is like a common format, but use Knative to deploy it. And also, all these cloud providers, when you look at it, at the end of the day, they all have these similar building blocks, right? They all have, you all have Amazon Lambda, Azure Functions, Google Cloud Functions, and then similarly running containers. I don't know Azure and AWS now, but I'm sure there's a way to run containers there as well. So I think the important thing is to have your services containerized. And then once you have the containerized, how you run the container can slightly differ from place to place, but at the end of the day, it's the same kind of things that you're going to depend on. I think one thing that you should really pay attention to is not the container itself, but the dependencies of your container. Like, for example, our container depends on a Firestore. Now, if I code that into my container, then I cannot take my container and just run on Azure, right? So you need to make sure that your storage layer is pluggable, so that when you move it to different places, you can write a separate store, like say like Azure store or something like that, and then this Azure store would do the Azure things, like it would store it in a NoSQL database on Azure. So making sure that your dependencies are pluggable is one way, and then making sure that you run in a common container is another way. So if you have these two things in place, then I think moving from place to place shouldn't be a problem.
Okay.
Thanks.
Okay.
Mete?
Thank you, Mete. Thank you for your story. But last talk is have a good option. You can talk as long as you want, but but we have to finish this talk and go into to discussion zone in Zoom.
Okay.
And I wish you good luck and bye bye.
Okay, thanks very much for having me, and then I'll go to the discussion zone if anyone else has more questions. And thanks for hosting, by the way. Thanks very much.
Okay, thank you too. Bye bye.